Greetings to every one of you. So in this video we are going to discuss another important concept from operating system, that is types of operating systems. Basically there are many types of operating systems available. Among them the very popular are batch systems, multi-programmed systems, time sharing systems, multiprocessor systems, distributed systems, and real-time systems. Let us see one by one. First one, batch system. What is batch? Batch, it is a collection of jobs. On earlier days, the programs were prepared using punch cards. The programs prepared by the user, which can be given to a computer operator, and the computer operator only submit the jobs or the programs to the computers. So after execution, the results will be produced by the computers, and that will be collected by the computer operator and given to the user. Let us consider if the user jobs contain number of jobs like J1, J2, J3, J4, J5, 6, J7, J8. Let us consider J1, J2, J3, J4 are the COBOL programs. J5, J6, J7, J8 are Fortran programs. So this will be collected as one batch, and that is submitted to the computer first. So this is batch 1. After completion of this job, this batch, they will collect all these jobs together, given to the computer in the form of a batch. That is all Fortran programs forms batch 2. So that it is called the batch system. So whatever the jobs given by the user, and that will be submitted to the computer only in the form of the batches. So in this operating system, the CPU is kept more idle, especially during the input-output operation. So you are giving the cards to the card reader is reading the cards. By the time the CPU will be kept idle. So this is one disadvantage. So naturally it is time consuming and leads to slow. Number 2, it is multi-programmed systems. So in order to increase the speed of the system, they brought the concept called multi-programming. So in this, more number of jobs or programs are allowed to loaded into the main memory, that is RAM, and executed simultaneously. We can use the CPU efficiently. See, for example, let us consider we have the different processes P1, P2, P3. Now the CPU is executing process 1. Let us consider if P1 need to perform some IO operation. So during that time, what will happen? The CPU is kept idle, but in case of multi-programming, what will happen? It will be that switch over to next process. Let us consider it is executing P2. During that time, if P2 encounters some kind of IO operation, so immediately it will switch over to next process P3. So note that the CPU, it is not idle. CPU is always busy. So because of this particular reason, we can increase the speed of the system. Speed of processing can be increased. So CPU is used effectively and efficiently, that is one advantage. Similarly, the speed of the system, it is increased. These are the two advantages of multi-programmed systems. The third one is time sharing system. It is also called multitasking. It is an extension of multi-programming. So in this operating system, allocate a particular time slice to execute all the processes. Let us consider we have process 1, process 2, process 3, process 4. We want to execute all these 4 processes, and basically the process 1 require 3 milliseconds to complete its execution. Similarly, process 2 requires 4 milliseconds and process 3 requires 2 milliseconds and process 4 require 1 millisecond. So operating system, it provides equal time slice to all the processes. Let us consider 2 milliseconds of time. So what will happen? 2 milliseconds of time is provided to process 1, but which require 3 milliseconds of time. So what will happen? It require 1 more milliseconds of time to finish its execution. So automatically process 1 will be that is placed in the last of the queue. Similarly, process 2 require 4 milliseconds of time, but only 2 milliseconds is provided by the operating system. Again, process 2 require 2 milliseconds to complete its execution. So process 2, it is again moved to the last of the queue. Now the process 3 require 2 milliseconds of time. It is enough for the process 3. So automatically that is 4 to 6, 2 milliseconds of time. So 6th millisecond, that is the process 3 is over, and process 4 require only 1 millisecond. So from 6 to that is 7th millisecond, process 4 is over. So now 2 milliseconds of time is provided to P1, but again P1 process 1 require only 1 milliseconds of time. So that is 7 to 8, 8th millisecond, process 1 is done. Similarly, process 2 require 2 more milliseconds to complete this execution. So from 8th millisecond to that is 10th millisecond. So process 2 completed its execution. So at the 10th millisecond, all the processes completed. So in this case, the operating system, it provides the same amount of time slice to all the processes so that it is able to, that is finish all the processes completely. So that is the advantage. The CPU time is shared among all the processes. So naturally the speed of the system can be, that is increased. The fourth one is a multiprocessor system, in which the idea behind is it contains number of processors. So system contain number of processors, processor 1, processor 2, processor 3, etc., processor n. So each processor will take care of a separate process. Processor 1 take care of process 1, processor 2 take care of process 2, similarly processor n take care of process n. So it is advantage that in the throughput of the system can be, that is increased, improved, and the concurrency is there. Simultaneously all the processes can be, that is processed, and naturally which leads to the fastness, then less cost, because only one system is there and so many processors are connected with one system. So that being the case, the cost is less. Similarly, high reliability. So even one processor fails, the another processor will take care of that particular the load. Fifth one is distributed system. It is also called a network system. The same information is distributed to all the systems in the network. Say for example, the project work is going on and the information of that particular project is distributed to all the teams of the project. So even if one system fails, the other system take care of the execution. So the failure can be, that is avoided in case of the distributed systems. Then finally, real-time systems. It is used in real-time applications. Basically we have two types of real-time systems. That is, one is a hard real-time system and another is a soft real-time system. In case of the hard real-time system, in which it is time bounded, it is time stipulated, it receives some inputs, so immediately it should process that particular inputs. See for example, that is a flight control system, in which they receives the signals from the different sensors, so immediately that particular inputs should be, that is processed and responded. But whereas the soft real-time system, in which there is no time limit. So for example, through the sensors we are receiving some gathering some information like weather forecasting system, in which they are recording the temperature or humidity. It is not that you have to record the temperature on particular the second or the millisecond. It is not like that. But whereas in the hard real-time system, that is which is time stipulated flight control system, in which data must be processed immediately, they are time bounded. So in this video we have discussed the different types of operating systems, like batch system, multi-programmed system, then time sharing system, multi-processor system, distributed system, and finally real-time systems. I hope you understood the concept. Thank you. Keep watching.